Hello everyone, my name is Gaurav Bahalkar and I am Data Science and Business Analytics Intern at the Spark Foundation. So this is my first task of internship, which is prediction using supervised machine learning. So in this task, we have to predict the percentage score of a student based on the number of hours he or she has studied. So we have two variables, that is the number of hours studied and the score he or she has got in the exam. So here we are the importing some required libraries for the analysis, which is pandas, numpy, matplotlib and cburn. And then after we are reading the data from the URL. So after reading the data, I am getting the shape of 25 2, which means that there are 25 rows in the data and 2 columns. Here we can describe the data, or we can find the information about the data with the help of two functions, which is data.describe and data.info. From the data.info, we are getting the 25 null entries, which means that there are no null values in the data, so we don't have to take care about the null values. It also tells us that hours variable is a float type of variable and the score variable is an int type of variable. So we will plot the scatter plot of the two variables, where the number of hours studied is on the x-axis and the scores obtained is on the y-axis. So from the scatter plot, we can see that there is a fairly linear relationship between the variables, and this can be validated with the help of correlated coefficient. So we are using the different types of method to find the correlation, which is a Pearson and the Spearman correlation. In the both correlation methods, we getting the similar similar score of the correlation, which is 0.976, which is nearly 1. So which means it is a kind of positive value. So this means that there is a positive linear relationship between the two variables, which implies that if the number of hours increase, the score will also increase. So here we are plotting a distribution plots of the two variables, and we are getting that one variable are in a particular range and there are no outliers. In So here is a model which we are using. This is the linear regression model. In this, we are first dividing the data into train and test data sets. So 80% of the data is into train data set and 20% of the data into test data set. So in linear regression, basically what scikit-learn internally does is it finds a line. Basically it finds the slope and the intersection where all the points fall, but after seeing the scatter plot of this data, there cannot be any line in which all the points fall. So what scikit-learn does is find a line in which the difference of the predicted values of the line and the actual values of the point is minimum. So basically what we have to do is the sum of the difference of the predicted values and the actual values of the score has to be minimum, and this creates an optimization problem which scikit-learn solved internally. And these are and these are two outputs of the model, which is the slope of the line and the intercept, so which is denoted by M and C. So this is the target values and target value which we already got in the data, and the predicted values which the model is predicting. We are also plotting a distribution plot for the difference between the target values and the predicted value. So this difference is also very close to the zero, and it is in the range of -5 to 5. So it basically tells that a model is fitting well. So our main task is to predict the score of the student who studies for the 9.25 hours per day and here we are getting for this result is a 91.56% score for the student who studies 9 hours, and this is the model evaluation. We are using the two performance metrics for the model evaluation. First is mean absolute error, and the second is the r2 r2 squared score. So the r square score, we are getting the high r square score. So r r square score of 0.97, which is a good score, and basically it tells us that the model is predicting 97.1% of the data. So here we done our analysis on the data very well. Thank you for joining.